Hey everyone, it's great to be back. We're back on our weekly video chats where we talk with you about a topic on streaming, analytics, building data flows with Python, and of course, Bytewax. I'm here with Sander today, and today we want to share with you the Bytewax cheat sheet. We'll have a chance to talk to you more in depth about what Bytewax is, the building blocks behind it, and how you can get started building real-time data flows with Bytewax. So I'm going to go ahead and be going through this cheat sheet that our team has put together. We're going to start with this idea of the key building blocks behind it. We'll move into the data flow, and then we'll provide some examples. And next week, we'll have a chance to go more in depth on some of the key building blocks behind the operators, namely operators that are stateless, stateful, and some windowing. So I'm going to go ahead and zoom in on the cheat sheet. And Sander, I'll pass it over to you.
Thanks, Laura. Hi, everyone. So what is a cheat sheet? I don't really know. It's a sheet to help you cheat, I suppose. So this should help you cheat at your job using Bytewax, I guess. So the first concept we'll cover are some of the high-level mechanisms of Bytewax. Bytewax is data parallel, which means that each worker, and it is distributed, which means that each worker will get a set of the data, and how that's distributed is not for this session, but we can maybe cover that at a different session. So, but the idea is that the operations that you're doing on the data happen on each worker, and so that's kind of what you see on the diagram here below. So you can think of operation A being some transformation step, operation B, another transformation step, so on and so forth to D. And those operations happen independently on each worker. A worker is a thread, and then those can be split across processes. So you can have multiple processes with multiple workers. And all of that comprises what would be called a cluster. Underneath Bytewax is a processing engine called timely data flow. And so that's a timely data flow cluster, essentially, of workers. So that's kind of the first concept, worker and a cluster. Now, important to a stream processing system, more so than a batch system, we have recovery. As you're progressing through the data, if something fails, you need to recover from the last good known point so that you can not have or not suffer from duplicates or missing data. And so Bytewax manages syncing up the state for each worker into a more durable storage layer, and that can also be backed up into the cloud. And then finally, what we see here about partitioning is just, so when we mention the data is parallel, that data is partitioned, generally based on the input mechanism. So if you have files or many files, how can you partition those files? Or if you're using Kafka and you're reading from a topic, there are partitions in Kafka. Unless something stateful occurs, we don't care about routing data from different partitions onto different workers. But in a stateful step, data will have to be moved so that you have the right data on the right worker. Say, for example, I'm counting how many times a user does an activity over time. I want to make sure all the data for that user is on one worker. So Bytewax will exchange data based on the key.
Awesome.
I think that's I think that covers that part.
That sounds great. So I think these are good building blocks to part from. And one question that I received quite a few times is, how much control do I have over how the partitioning is being done? So you mentioned some of this is dependent on the source, whether it's coming from files or from Kafka. But let's say that I wanted to create my own custom partitioning. Is that something that is happening behind the scenes based off of the scenario, or is it a mechanism for creating the partitions manually?
Yeah, so the Bytewax API, the input API, has a source and then a partition class. And the source class will call the partition classes. And so the source basically says, these asks for what are all of the parts, and then instructs the system to go build those parts. And then when you go build those parts, then you have the individual partition class, which is something like the consumer, and that's going to run on each partition. So you can put logic in each of those on how you distribute your partitions. Let's say, for example, and you can do it in a kind of dynamic or in a fixed manner. For example, what we do for Kafka, with the Kafka connector, is we request from the broker what are all of the partitions for that topic, and then we distribute those partitions. I mean, using partition twice, but so that topic is split up into things. We take each one of those split things and we distribute them across the workers. So you can have more fine-grained control to a point.
Gotcha. Now, all of this, when evaluated as it sounds quite complicated. But one of the things that you mentioned, and I think this is a really nice way to segue into the next topic, is the Python API. So you mentioned that it is built on Rust's timely data flow. But today we're going to be focusing on the Python API, which allows you to build some of these data flows. So this leads us to the next phase in our data sheet. In our cheat sheet, which is, now that I know what's going on behind the scenes, how do I actually get to put all these things together and build a data flow? So the key building blocks for this include the data flow, which is just a class that represents the data processing pipeline. With it, we're going to define the sequence of operations. We can think of these as steps. If we think about a data flow as a directed acyclic graph, we have our nodes as the steps and directed edges connecting those steps, indicating input, a map operator to process into, let's say, cleaning or filtering, and then some output, which can either be to the console or it can be to some kind of connector, such as a database or an application. So for this week, we're going to have a chance to see these examples through Python snippets. Next week, we'll have a chance to take a look at the operators in more depth, and this will allow us to see this idea of partitioning a little bit more in depth. So with this, I'm going to go ahead and jump into some code snippets. So Bytewax can be installed through a pip command. You can find us on github.com/bytewax. If you like what we do, we really appreciate a star. Issues or pull requests are also welcome. And you can find our documentation on docs.bytewax.io. So I'm going to go ahead and get started. So let's jump into this idea of what the data flow is and how what it looks like once we're actually building using something like Python. So the key things to remember are we want to initialize our data flow, we want to initialize our input source, and then we want to apply some kind of operator on that input source to transform the data from its raw format to whatever format I desire. The main idea of Bytewax, of course, is, your data source can be anything from edge devices, events, applications, and databases. So Zander, you mentioned Kafka as one of these examples. And then I have interfaces that allow me to take the data from these sources and read them, transform them, and then output them using the Python ecosystem. So it can be that you transform the data from, IoT device into a data warehouse, or maybe you want to serve the results as an API application or some kind of dashboard. You can pass it on to a database or streaming syncs. And this idea of sync is enabling you to obtain an API or interface to communicate with different services, Azure being one of these services, or ClickHouse being one of these services. And we're currently in the process of releasing syncs for different providers to make it as easy as possible for you to connect. So let's take a look at a simple data flow. So I can import the different ingredients. In this case, I'm going to be focusing mostly on the data flow and the operators. And then these other ones right here are for assessing and testing that the input and output are working okay. So this very simple example is just going to take a list of words or strings, in this case, the strings apple, banana, and cherry. And all I want to do is I want to apply the upper method on these strings so that the data flow returns or applies the upper method on each of these strings. Now, typically, if you were to do this in something like a for loop, you would do for item and list item dot upper. Now, if you're dealing with a stream of entries. Let's say that you're not dealing with a finite list of strings like we're seeing here, but we have a stream of strings that are constantly going through, let's say, a news articles or I don't know, some kind of source, then at some point the for loop becomes very cumbersome. I don't have this ability to partition or parallelize. Now, the beauty behind Bytewax is, yeah, go ahead,
One question.
Zander. Yeah.
So, you mentioned similar to a list. So does that mean, does Bytewax load all of that data, or is it just loading the data into memory, each item into memory? Is it like lazily loading, or is it more similar to the way the Python list would work, where it's all loaded in memory and then it's interacted with?
Oh, I'm getting a trick question here, Zander. I actually don't know the correct answer to this question. What is the correct answer to this question?
Well, should we keep that in? No.
Yes, no. It's actually a really good question because this ties back to this idea of performance and this idea of scalability. So I would, yeah, go ahead.
I think the best way to know what's going on is to kind of look what's under the hood of the source. But underneath the testing source, you'll see a yield. And so what you're actually making is a generator object. And so you kind of have a handle into that iterator, as opposed to, so it's more like lazy loading.
Lazy loading, gotcha. So in this case, instead of me
if you know
loading
what
the
lazy
entire,
loading is, then it will make sense. If you don't know, then I guess it's still.
yeah. So I understand what you're saying. Instead of me reading the entire list, apple, banana, cherry, I just yield one element at a time as I need, not
Yeah.
all of them at once, but rather an element, each element as I need that specific element.
Yeah, you can think of it saying like, give me the next one, give me the next one, give me the next
Yep.
one. And then that gives you the ability to control how fast you ask for the next one too. And so a very eager system would say, give me the next one, give me the next one, give me the next one. Or you could say a less eager system will give me the next three.
Or give me the next one every 10 seconds.
Yeah, give me the next one every 10 seconds. It gives you that like fine grained control on how you're consuming.
Gotcha. Thank you. And so in this case, the key steps or the way we would go about building the data flow is we initialize our data flow instance. In this case, I gave it a name. You can give it whatever name you want. I gave it the name uppercase. And then from here, we add our input through the input operator. What this is going to take as parameters is some kind of name. In this case, I gave it the name IMP, but I can call it input as well. I want to pass my flow variable. And then from here, I would pass an input source. Now, this is where things get interesting. In this case, I'm using the testing source, which comes from Bytewax testing. It's making life a little easier for me to just simulate things. But you can change this to other sources, like we have a file source. You can connect it to a Kafka source, etc. So you're not quite tied to having to build these things from scratch. We provide this functionality to connect different sources. And a quick question here, Zander. Does this idea of connectors and syncs enable me to build connections to other sources that may not necessarily be developed at this time?
Yeah, with the input API, you can also write your own, and you have the controls to partition as well as to poll at intervals, and control the number of items you receive at each poll. So you have all of the bits and pieces to write something that can go fast or slow, high throughput, low throughput.
Gotcha. Thank you. Now, in this case, the way we apply our next step. So once we loaded our data, my goal is to apply the upper method on each of these strings as I call them. So in this case, I have two methods of doing this. I can either define a function, then define a new operator. In this case, I'm going to use the map operator. I gave it a name. I pass the previous step. In this case, it was the input. And then in here, I pass the name of the function. The alternative way of doing this is through the use of lambda functions, in which case, instead of me having to define a function, I simply say, okay, uppercase, I take as input the IMP variable or the input variable. And then instead of having the function as I defined it before, I can just say lambda x and then apply the upper method on x. So these are two ways of doing it. Now, in this case, I'm adding an inspect. I'm using the inspect operator and run main to execute this from my Jupyter notebook. If you wanted to run this from the terminal, typically what we would do is we would have the output operator and we pass the name of this step, what it is that I want to output, in this case, the process step. And then here's where this idea of the sinks come in. So in this case, this sink is just simply going to return on the terminal what it is that the data flow is doing. But as before, this can be either a connector to a database, say Azure or say ClickHouse or whichever connector you want to plug in. And then from the terminal, we would typically run something like Python -m bytewax.run data flow if your Python file is called dataflow.py, and then flow, in this case, the name of this flow variable. We can also do things like visualize data flow, and this will generate a mermaid graph of the different steps that the data flow is following in this case. And then to finalize this video, of course, we want to talk about deployment. So once you have a data flow in a .py file and you have your data source, you have your input sink, you process the data through some kind of operators, and you return it or output it through the use of a sink. The next phase, of course, is, well, how do you manage the data flow? What if I have multiple data flows? How do we go about doing something like this? So for this, our team is developing a Wax control, which allows you to install a command line interface, command line interface that allows you to manage the data flows and deploy. So typically what this would look like on the terminal is I would run wax control dataflow.help, and you can manage your data flows in Kubernetes, and you'll have a chance to delete, deploy, and list. And one question that we receive quite often is, where can I deploy these? Is it local? Is it on the cloud? Is it on an edge device? Tell me more about this. So Zander, where are we able to deploy and manage the data flows as of today?
As of today, you can, with Wax control, you can run locally. So you can Wax control run. You can deploy to your Kubernetes cluster, or you can deploy to the platform, which is our platform that is the commercial offering, or you can run it on a VM on Google Cloud or on AWS. So if you provide your credentials and you say Wax control AWS data flow deploy, you'll run a data flow on a AWS VM.
And I heard you did one fun experiment of deploying a data flow, and I'm not sure if you were also running the platform on a Raspberry Pi. Can you tell us more a little bit about how this went down?
Yeah, well, it happened. It took me a little bit to get it working, but because my Raspberry Pi was very out of date. But once I had a more recent Python version, and then I could and I had K3s installed, I could run the platform on, which requires Kubernetes. So I could run the platform on Kubernetes, and then I could run some data flows on Raspberry Pi, which was
That is pretty awesome. So this is it for today's session. Next week, we're going to have a chance to look at the operators in more depth. We're going to take a look at this idea of stateful versus stateless operators, and we'll also have a chance to talk about this idea of windowing and its role in stream processing. So just as a quick recap, so today we had a chance to see a quick overview of what the Bytewax platform is and how it enables us to do streaming and stream processing using Python. The key concepts we focused on was this idea of cluster, worker, recovery, and partitioning as what's going on behind the scenes. And then through the Python API, we can easily build these data flows where the assumption is I'll initialize my data flow, I set up some kind of input source. The input source can either be something that is user-defined, it can be a file, or it can be something like Kafka topics. From here, the next step is to use operators. And next week, we'll go more in depth onto this idea of what operators are, the difference between stateful and stateless, and windowing. And the output then is to, or the next step, sorry, is to output it in to some kind of connector sync, which can be either your terminal or it can be a database, an application, or a data warehouse. So this is it for today. Thank you so much, Zander, for going through Bytewax more in depth with me, and we look forward to seeing you in the next section.
Thanks, Laura. Bye-bye.
Bye.